So I think presently we are studying the moment of inertia for different objects. Like we have studied a rod, and then we studied a ring, and then we studied rectangular lamina, and then last class we studied a disc. So now in our today's class we are going to solve the first one numerical related to disc, and then we are going to solve cylinder, hollow cylinder, a solid cylinder, and XYZ. So last class, if you observe that, we have derived that finally. So if you take the ring, so what is the moment of inertia of a ring, everybody? So moment of inertia of a ring, we have got it what? mr square. And moment
by 2.
of a disk, we have derived it. What is the final answer? mr square divided by 2. What is the difference between the ring and the disk actually? So disk is mass is distributed. Understanding? At every part mass is distributed. But if you take the ring, whole mass of the ring is present only at the where? At the surface, that final. So inside and all it is about actually hollow, empty space it is. So entire mass is located only at the surface. That is what is actually we used to say ring. But disk means every particle mass is every part mass is distributed. Only middle it will be having some hollow space. So now, so with the help of this, we are going to solve one numerical and then we'll proceed. So first write the question. So draw the question first. It's not even writing. So just to take one hollow disk only. So particular part of a disk I am taking. So you can all see how I will draw. According to that, you also can make it. Okay. So now from the center, so let me choose it. So from the center to the first one is R1, and from the center, the second one I am taking as what I will take it as radius, which I will take it as a R2. Okay, for those. Now this is the COM. What do you mean by COM? The center of mass is located at the middle. So that is what is the COM. Now you can see, so from here to here it's a hollow, and but here to here it is having a mass. So that is what M. What is the mass of the body? All of you? Mass of the body is how much? M. So this entire part is having a mass. Just imagine, I'm highlighting. You can draw with the lines. So just this is the part which is having a mass is located. So the mass is that whole body I will assume as a okay. So particular mass M, the total mass of this one. So everything everywhere it is present. Now let us see. I will take a particular part of it one. If I take a particular ring, we all know, imagine like a disc. So yesterday's class we have done it the same way. So particular part if I have taken, and it will be like what we have done in the yesterday. That is what it will be. So from the center it will be R, and this is all the particular region I have been cut. That is a small part. So if this total is M means, then this particular part will become what? All of you? Yes, Pradosh. The particular part will become what? dm, and this particular radius will become what? dr. So having a radius is dr and having a mass of dm. Now we all know it is we can form many rings here, so that I am taking up one ring only. So the moment of inertia of this small ring is what, everybody? Moment of inertia of this small ring is equals to what? Di is equals to, please respond, dm into, all of you, dm into r square. Am I right or not? Dm into r square. Now we have to form many rings is forming. So this is r1 and this is r2. See, from this point to this point, many rings we can form. So we have to apply what? Integration. So integration of di is equals to integration of dm into r square. Are you clear, everybody? Yeah. And what is the limits? Can you tell me the limits? Limits is taken from the center of mass or only from the R1 to R2? Because mass is located where to where? Check it, everybody. Mass is located from R1 to R2. So what is the limits, guys? Limits is where it's from where to where? R1 to R2. Now, We want to know what is this dm. So how to find the dm? You can see. So if I cut it and if I make it into a straight line, so the total length will become what? 2 pi r, and the thickness is becoming dr. So what is the area of this one? Anybody can tell me? Area is equals to what? 2 pi r into 2 pi r into dr. You all should say I am not. Now we all knows that it is area, so that we have used a constant. Mass per unit area or mass per unit length? Mass per
unit area.
area. So sigma is equals to, we all knows that total mass divided by total area. So can you tell me, Pradosh, what is the total area? See that middle hollow sphere is there. So what is the total area? I will find the total area of the big round and I will remove the total area of a small round. That is what will give you the remaining area. Will you all agree with me, everybody? I will find the total area of a big round and I will subtract the total area of a small round. And that is the remaining area which is present, because there only mass is existed. Am I right or wrong? Everybody, Rudreswa, do you understand what I am saying? Yes? Please respond. So the mass is located only at this region, so that I want to make it only what? This is the region where the area is present. So how to find this area? Anybody can tell me? Mathematics, how we can do? So we'll find the area of a big round, area of a big one, and we'll find the area of a small one, and we'll subtract the area of a small one from the big one, and we'll get the remaining area. Is it right or wrong? Please respond, guys. All of
Yes,
you?
sir.
Yes. So means what will happen here? Sigma is equals to, we will get it. Actually formula is what? Sigma is equals to m by a, means m by pi r square. So pi r square, when only single round is there. If it is a ring what we have done? See the process. Ring is equals to what? R is remains constant. So we can say it is even single dimensional. We can say if it is a single one, we can say pi r square. But we want to subtract it. So what will happen? Anybody can tell me? Pi into r2 square minus r1 square. So that is the sigma. Understand, Narayan? Rudreswa? That is what it is. Because it is mass per unit area. So big ring minus small ring, if I do, I'll get the remaining area where mass is located. That is what I have to do it. So area is 2 pi r. So we all knows that, all of you. So if area, this is the mass per unit area. So we all knows that if it is 1 square meter, mass is 1 sigma. If it is a 2 square meter, mass is 2 sigma. If it is a 3 square meter, mass is 3 sigma. 3 sigma. If it is dm mass, what is that area? If area is now, area is how much, everybody? 2 pi r dr. Can you tell me what is the mass? Anybody? What is the mass of it? All of you. 2 pi r dr into, so that is the mass of the dm. So I'll replace the dm. So integration of di. What is the integration of di? Everybody. Integration of di. How much, guys? I. So I is equals to integration of r1, r2. dm means what, guys? All of you. dm means what? 2 pi r dr into r square. So now here r value, you tell me. Is it remains constant? What are the constants? You can notice it. Oh, sigma is missing. 2 pi r dr sigma. So now sigma is mass per unit area is remains constant and 2 pi is constant. So can I bring it outside, everybody? 2 pi sigma is equals to r1 to r2, and what is remaining? R into r square. R into r square, what, guys? R cube. R cube into dr. Okay, that's all it is. Now sigma value we all knows that. So 2 pi into, what is the sigma value? We have been found it here. What is the sigma value? Mass per unit area. How much, guys? M divided by pi into r2 square minus r1 square. So pi will get cancelled into integration of r cube. How much? Rudreswa, r4 divided by 4 and roots is r1 to r2 limits. So answer is 2m divided by r1 square minus, sorry, r2 square minus r1 square into limits. If we substitute it, r2 power 4 minus r1 power 4. So this is what it will happen. Anybody having any doubt here, you please respond. Are you clear? Pradosh? Understanding?
Yes, sir.
Yes. Now this one you can see. Can I write this one as like this? Check it, everybody. So I'm having like this one, a power 4 minus b power 4. So can I write it? This one is mathematics some other way. Can you tell me? Like I can write a square whole square minus b square whole square. So a square minus b square, what is the formula? Anybody? A square minus b square
Plus
formula.
B into A minus
Yeah.
B.
A plus b into a minus b means a square plus b square into a square minus b square. Will you all accept, Rudreswa? Pradosh? So that is what we can say. Because here a means a square, b means b square. Is it okay, guys? Respond. Yes?
Yes, sir.
Same way I can write here. So 2m divided by r2 square minus r1 square. This one how I can write? Modify it and tell me. How you people can write? Oh, divided by 4 is there. Sorry. Here divided by 4. Here also divided by 4. Because I forgot the 4. 4 is there. Okay. So now I will take LCM. LCM as a 4. 4 is the LCM. So you will get R2 power 4 minus R1 power 4. So R2 power 4 and R1 power 4. How I can write, guys? Everybody? Just now here we have written, guys. So tell me. R2 square.
R2 square plus R1.
R2 square plus R1 square into R2
R2
square
square.
minus R divided by 4. So 2 ones are 2 twos are. So R2 square, R1 square. This is will get cancelled. So what is the remaining thing? Verify it. So M into R2 square plus R1 square divided by 2. So this is the answer. So moment of inertia, if I have taken, so I is equals to, what will happen? M by 2 into, you can see that I is equals to M by 2 into R2 square plus R1 square. Or I can say M by 2 into R1 square plus R2 square. Both are same. I hope you all understand, girls. Everybody. So that is the way we need to solve the moment of inertia of a you can take a so like we can say a disk. Okay. So now disk, they are asking moment of inertia from R to R, not from particular place. R to R they are asking. Do you understand, Ra? So by that time, basically what is the moment of inertia of a disk? Everybody, formula. What is the moment of inertia of a disk formula? Mr square by
Square by
mr square by 2. Now from R to R they are asking. So that what is the moment of inertia? M by 2 into R1 square plus R2 square. Here we are getting M by 2 into R square. Now here between two radius they are asking. So that is why R1 square plus R2 square. Directly you please remember that. Are you clear? Very, very important one. Any doubt, anybody can ask me. If you are understanding this, then we'll proceed further. Very, very important. Clear, everybody?
Yes, sir.
Any doubt, you can ask. Do you understand, Mr. Udreswa? Girls, any doubt? Mr. Narayan? Sai Karthik?
No, sir.
Okay. So this is what about it. Now with the help of this, so we are going to find next one, cylinder. Cylinders, different cylinders will take it. So first cylinder, it's very simple. It's a very logical way and easy way will solve. So if you take a cylinder, so cylinders two types. Can you tell me what is the cylinders types you can find basically? Yes,
hollow cylinder.
I will give you hollow cylinder. I will give you solid cylinder. So definitely solid cylinder means inside there is a gap or not? No gap. Correct or not? So no gap. Cylinder, hollow cylinder means completely only mass is completely located where? Like a ring, it is only located on the surface. Am I right or wrong? All of you? So completely hollow cylinder. Okay. So having a mass M and radius R. So completely hollow cylinder means inside is there any mass or not? That is what I miss question. Everybody? Completely
No,
hollow cylinder. Is that inside mass is there or not? All of you? Please respond.
no, sir.
No. So now if I have taken this is what is completely hollow cylinder I have taken. Now tell me, completely hollow cylinder means how it will forms. It will be having infinite number of rings. Am I right or wrong? So if I make one ring, if I copy one ring, okay, so it will be turn up into what? All of you. So the if I turn up into, it will turn up into hollow cylinder. So many infinite number of rings, if I place it one above one, that is only will gives you the hollow cylinder. Will you all agree with me that, everybody? So just for example, I'm saying. So infinite number of rings has been attached one after one. So that is how we will get hollow cylinder. Is it right or wrong, everybody? Yes? Yeah. So now if you have noticed it, if you take this hollow cylinder, so we have to make it, the question you write first. Calculate the moment of inertia. Calculate the moment of inertia. Calculate the moment of inertia. Moment of inertia of a hollow cylinder. Of a hollow cylinder. Of a hollow cylinder. Completely hollow cylinder. Completely hollow cylinder. About an axis passing through the, about an axis passing through, about an axis passing through axis of cylinder and center of mass. About an axis passing through axis of cylinder and center of mass. That is the question. So what is that? Axis of rotation passing through the center of mass and as well as axis of rotation also. So means the axis of rotation is exactly passing like this. Do you all agree with me, everybody? If you are responding only, it will be good. Otherwise,
Yes, sir.
Yes. So this is the meaning of axis of rotation. So axis of rotation is about an axis passing through the axis of cylinder. So axis of cylinder is, this is only the axis of cylinder. Cylinders will be rotate like this if you are rotating also. So this is what is the axis of cylinder, and axis also passing through this only, and center of mass also. So center of mass is located exactly at the middle. So now if you see, if I cut this cylinder, definitely it will be having infinity number of rings. Will you all agree with me? So this cylinder, if I make particular part, if I cut it, so there is a one ring. If I cut this particular part, there is a another ring. If I cut particular part, there is another ring. So like that, every cylinder is made up of infinite number of rings. Am I right? Will you all agree with me? So by infinity number of rings kept one over other, kept over one another, so we will get a hollow cylinder. Is it right? No response. Okay. So now particularly I will take one ring. So let me take this particular ring. All of you observe. So I am taking a small ring whose mass is dm. Whose mass is dm, like a ring. Like a ring. So can you tell me what is the moment of inertia of a small part of a ring? Anybody? We all knows that. Ring, moment of inertia. Moment of
MR
inertia of a ring, ra. Basically, moment of inertia of a ring is what? M into R
M
square.
MR square.
I'm taking here many rings are there, brothers. Many rings. If mass is M, MR square. I am taking here dm, small mass, small ring. So that what will happen? dm R.
DM
Because
square.
next, R is remains constant of Verisa. Mr. Pradosh, from every ring, R is remains constant of Verisa from center.
Constant, sir.
All of you. So R is remains constant. That is also very important. So I want many number of infinity number of rings is there. So I want to find total. So that what is what you need to apply? Integration. So integration of dm divided dm R square. So we all knows that R is remains constant. So that what integration of I is integration of di is I. R square will be constant. So we'll get dm. So we all knows that small mass is dm. So dm plus dm plus dm I will add. I will get the what mass? Everybody respond. I will get the total mass. So integration of dx is x. So the same way integration of dm is what? M. So I will get I is equals to what is that? Everybody? M R square.
MR square.
Same thing. So ring and hollow cylinder, both moment of inertia is remains same. That is what just I want to say. I hope you all understand, everybody. Clear? Cylinder, which cylinder it is? Completely hollow cylinder. Okay, so completely hollow cylinder whose moment of inertia and ring moment of inertia is both remains same. So that is what you have to remember. Okay, guys, all of you completed? If you completed, then we'll proceed further. Okay.
Yes, sir.
Next, cylinder. What is another type of cylinder? I'll take. Everybody, this is also a cylinder. Same about an axis passing through the axis of cylinder. Mr. Narayan, what is another type of cylinder you can take? Yes, please, everybody. So cylinder, it is a solid cylinder. Okay. So if I take a solid cylinder, so solid cylinder means inside hollow or fully filled with the mass. Mass is distributed or only fully in the surface? Everybody?
Mass is
Fully distributed.
Mass is distributed. That is what it is. So mass is distributed means you might be understand by this time. It is a what? It is a ring or disc? Ring
Disc, sir.
or disc? Mass is distributed. Ring or disc? Everybody?
disc.
It is
Disc,
the
sir.
okay. So I will fill with the color so that you all understand. So shape is filled with let me take it. Now you can see that it is a disc or ring. Everybody? So it is a three-dimensional one. So mass is distributed everywhere. You can take, for example, particular part if I cut it. So the mass is distributed everywhere. Am I right or wrong? All of you? Please respond.
Yes, sir.
That is what. So it is a 3D, three-dimensional one. So this is also formed by what? Infinity number of discs placed over the what? Over one another. Understanding, all of you? So infinity number of discs is placed one another. We are getting the solid cylinder. So I will select any particular solid cylinder. Okay, a particular disc I am selecting. I can cut it into infinity number of discs. So particular disc I am selecting. So whose mass is dm. Okay. So if I take the total disc, whole mass is m. So that disc, what is the moment of inertia? We got it. M by 2 r square. Just now we have studied also. Am I right or wrong? M by 2 r square. Now I am choosing only small dm. So that what is the moment of inertia of the small dm? Everybody, small disc, which is equals to what? Instead of m, dm r square by 2. Is it okay? Wa? Yes, girls. Please respond. So that is what it will be happening. Okay, guys? For those?
Yes, sir.
Yeah.
Yes, sir.
So that is what it will be happening. So now what else is there? Many rings, many hollow not solid discs are there. So one disc is this one, small one is dm square. Now we want to find many, so that integration. So integration of di is equals to integration of dm r square divided by 2. Now if you notice it, again same. From the axis of rotation, r values remains what? Radius. Yes, please.
Constant.
Yes, sir.
Understanding? So from the axis of rotation, r values remains constant. So because I am taking this entirely solid, it is. Please remember. So it is not a ring, solid. So it is, that is what it is. So r is remains constant. So car2 also constant. So r square by 2. R square by 2 integration of dm, which is equals to I. Integration of di is I. Now small mass is dm. So all masses is adding dm plus dm, which will gives you what? Everybody? Total mass. So integration of dm is capital M. That's all. So moment of inertia is equals to what? Everybody? R square by 2 into m. So which is equals to m r square by 2. I hope you all understanding, everybody. Solid cylinder and what else? Disc. Both moment of inertia is same. Are you clear? Yes? All of you?
Yes, sir.
Now, we have seen today's beginning class. It is not exactly a disc. Disc means wholly it is mass is distributed. So now here, it is not complete disc we have studied in the first class. What we have studied today's first example. It is a disc, but middle it is having a what? It is a disc, but
Hollow
middle it is having a what, guys? Empty space, hollow. Am I right or wrong? So means whole mass is located between R1 and R2 only. Am I right or wrong? Please respond, everybody. Yes, please. So now I will choose a cylinder. All of you check it. So it is not a completely hollow. Hollow cylinder who's having a, like inside, one cylinder is kept inside another cylinder. So you can see that. So that is kind of things. Like you can say, this is a one cylinder and I kept another cylinder which is inside. Means mass is located between them. So this is what it is. Are you understand, brothers? Rudreswa? Clear?
Yes, sir.
Yes. Now, in this case, what is the moment of inertia? So, one cylinder is inside the other cylinder. So, let me take this is R1. R1 and from here, so let me draw it. Okay. So, from here, this is what everybody? It is R2. Okay, wa?
R.
Understand everybody? From the axis of rotation. If you want, you can draw the axis of rotation also. Now we want to find moment of inertia. Just like today's class, what we studied. Now this one, if I cut it, I will get many number of disc, but middle it is a hollow. Am I right or wrong? Will you all agree with me? Mr. Narayan, Pradeep? Yes or no, guys? So we'll get a ring, we'll get a cut.
Yes,
If
sir.
I make it a particular part has been cut, so how I will get it? I will get like this, middle hollow, and this is what I will get it. So this is the mass where whole mass is located. Just what we studied now today's class. Am I right or wrong, everybody? So from the center, this is R1. From the center, this is R2. Okay, wa? Respond, Ra.
Yes, sir.
Yes. So what is the moment of inertia of this case? M by 2 into what we have studied?
R.
R1 square plus
R2.
R2. Okay. R2 square. That's all it is. We can solve it now very simple. Now particular part I have taken whose mass is M. Whose mass is M. So that what is the moment of inertia? Everybody. So the moment of inertia of the particular particle. This is dm, small m. Dm I have taken. One disk, small disk. So which is equals to what? If it is a total mass. So small mass means dm divided by 2 into r1 square plus. You speak only correct will come. What me I knows. So integration of which is equals to dm by 2 into r1 square plus r2 square. Now here if you notice it. So always what is remains constant, everybody? Radius will never change. If I cut any disk, if I cut any part from the center R1, from the center R2, remains constant or varies off? Everybody?
Remains constant.
Constant.
Constant. So integration of di, which is equals to R1 square plus R2 square divided by 2 in integration of dm. So integration of di is I. So I is equals to R1 square plus R2 square by 2. And integration of dm is what, guys? Integration of dm is equals to what? M, total mass. Understand it? All of you? So what is it? What will happen? Hollow cylinder, not completely. Hollow cylinder, not completely. Completely hollow. Not completely hollow. So that what will happen? I is equals to, what is the moment of inertia, brothers? M by 2 into R1 square plus R2 square. I hope you all understand what is a cylinder, types of cylinders and moment of inertia related to that. How it will be related. Any doubt, anybody can ask me. Are you clear, guys? All of you?
Sir.
Please
Yes,
respond.
sir.
Yeah. So this is what is about hollow cylinders, not solid cylinder and not completely hollow cylinder. Partially, one cylinder is kept inside the another cylinder. So this is how moment of inertia. Okay. Now the last one we are going to study. So the moment of inertia. So that moment of inertia concept will be over. Evening we are going to start the next concept. So calculate it right. Moment of inertia of a triangle. Triangle lamina. Rectangular lamina, I think already taught you. Am I right, Rudreswa?
Yes,
Yes.
sir.
Yeah. About its axis, about its base. See that. Moment of inertia of a lamina, triangular lamina, about its base. Means axis of rotation is passing through the what? Axis of rotation is passing through the what? Base of the triangle. Mass of the triangle is M, height of the triangle is H, and base of the triangle is B. So this is what it is. Now all of you check it. We want to find the moment of inertia about its base. Means axis of rotation is passing through where? Axis of rotation is passing through where? Everybody. About its, please respond. About its base. Okay. So that is what is called as moment of inertia. So I have taken, this is what is my triangle. So now about its base, it is rotating. Means this is what is my base. Do you all agree with me, everybody? Yes. So it is, this is what is the axis of rotation is passing. So about its base, it is actually rotating. So this is what it is. Now they're asking us to find the moment of inertia. So I'll make it and I'll make the things correct. So this is the axis of rotation. Okay. So the base is B. This is the base of the triangle. Okay. And height of the triangle is H. Height of the triangle is H. Okay. What is the height of the triangle, everybody?
H.
Height of the triangle is H. Now we want to find the moment of inertia. Okay, brothers. Shall we start? How to find it?
Yes,
Everybody. So imagine particular part. Again, same thing. I'll cut it into different pieces. So I will find a small mass, small dm. I will take it this particular part. So you can check it. Any part I can take it, which is away from that. So I'm taking anywhere, bottom or top or anywhere. So I'm selecting this particular part whose mass is dm. Whose mass is how much, everybody? Whose mass is dm. And from the base, it is above from the distance called as y. Let me take it. So imagine it is rotating about this axis of rotation. Understand, Rudreswar? Just you stick the triangle to the stick, and if you're rotating like clockwise or anti-clockwise, how the triangle will rotate? It will take rotation like this. Am I right or wrong, everybody? Please respond, guys. All of you? Nobody will say. So that is what it is actually it is. Now we want to find the, what is that? So let me take the thickness of this one is dy and mass is dm. So now you tell me, from the axis of rotation, this particular point we used to call something. Actually, from the axis of rotation, particular point we used to call something. What is that called as? We can choose x, or we can choose y, or which is equals to finally what? Distance, r. Correct or not? All of you. So integration of di, which is equals to integration of mass of the particular part is dm, and r is y, so that y square. So this is what I have been done. Now if you calculate the dm, it is over. Now let us see how to find it. So a particular part I have been selected whose mass is dm. Let me draw that particular part here. So I know the thickness is okay. Thickness is how much it is actually, I assumed as a dy. And now length, if you check it, length is, suppose if I choose this particle, is it length is remains constant or varies? That is what is my question. Is the length is remains
Varies.
constant or varies? Everybody? Definitely it will be varies.
Varies.
Right or wrong? So that area is equals to what, brothers? Area is equals to what? Length into dy. Length into breadth, L dy, and mass. If see that area, this mass is, see, we all knows that 1 square meter means 1 sigma, 2 square meter means 2 sigma. Now dm, sorry, yeah, you can take dy square meter means dy sigma. Now we want mass of this one. So mass of this one, how much it will become, everybody? L dy sigma. Are you clear, everybody? Please respond, guys. All of you. So L dy, not. So L dy sigma means, so dm mass is equals to L dy sigma. So dm is equals to L dy into sigma. Will you all agree with me? Please respond, Ra. All of you? Yeah. Now, we all knows that sigma is equals to, what is the formula? Mass by area. So mass by area, what is the area of a triangle formula? Area of a triangle formula. Half into
half into base into height.
into height. So which is equals to sigma equals to, can I say 2 will go up 2m by bh. Will you all agree with me? Yes, please.
Sir.
Will you all agree with me, guys?
Yes, sir.
Yes. Now,
Yes, sir.
but here the problem is, I know the sigma everything, but L is remains not constant because so L dy, I know sigma also, no issues. But you can see, I choose the L here, but Mr. Prados will choose the L here. Understanding? And Rudreswar will choose the L here, or some other will choose the L here. But then tell me, is it L remains constant? That is what is
L
the
varies.
L varies. So L varies means, observe Prados, there is a mathematics concept you observe. So I will draw the triangles also. Meeting is going to end. Again, you join fastly so that we can make it. So let me see that I have taken a triangle now. I have taken a particular part. Your choice, you can take. So this small region I have taken. Now see, it is forming a two similar triangles. Am I right? Mathematics 10th class concept. You can see that. Say I have taken this particular region. Now see, it is forming a two similar triangles or not? Outside big triangle, inside small triangle. Will you all agree with me? Yes?
Yes,
I have
sir.
chosen this part. So now let me take this part is A, B, C, and this one is D and E. Now see, ADE is similar to, it is a similar triangle to, what triangle? Big triangle. What is that?
ABC.
ABC. So both are similar triangles. So similar triangles means you know some property. Similar triangles
Sides are
means
proportional.
what
Sides are
is what is constant, guys? Similar triangles means what is that? Side ratios are what?
Proportional to each other.
Side ratios are same. That is what it is. Similar triangles means side ratios are same. So what is the side ratios? Check it. What is the total height, everybody? Total height of the triangle is